Now as we done the sum of series, that is AP series and GP series, where we learn how can we find the sum of n terms that involve JP and AP series. Now we will discuss sum of some special series. That is, in this topic we will learn such as sequence of, powers of natural numbers. That is, if 1 become 1 square, 2 become 2 square, 3 become 3 square, and when we have to find the sum of this series, or we have to find the sum of 1 into 2 plus 2 into 3, just such like series. So such type of series are called special series. As we have obtained formula for sum of first n natural numbers by an AP and a GP progression. But it is not possible to find such formula for every sequence, because there are some sequence which are neither AP nor GP, that is, these are not arithmetic progression and nor GP progression. They are different from these two progressions, and we are able to calculate the sum of their n terms. We shall consider such type of sequence as special sequence. For this, we shall introduce a notation that is sigma, pronounced as sigma, used for series that give the sum. So it is called summation. For example, n varying from 2 to 6, summation or sigma of T6, sorry, not T6, Tn. So as n is varying from 2 to 6 and there is sigma, that means there is plus sign, sum of terms involving T2 plus T3 plus T4 plus T5 plus T6. So this denotes the sum of these terms, that is sum of term number 2 to term number 6 of the given series. That is the involvement of sigma, that is the existence of sigma and use of sigma in series. As sigma exists in the notation of a series, now we will discuss the properties of symbol sigma. That is, the first property is sigma I1 to n sum of two series is equal to summation or sigma sum of first series plus sigma sum of second series. Number 2, sigma I1 to n m times ai gives m times, m is common out of each series, and then take the sum of each term, where m is a constant independent of I. The third property is, if we take summation or sigma I1 to n of a constant number, it can be written as summation I1 to n I raised to power 0, as I is varying from 1 to n and something raised to power 0 is 1. So we replace 1 by I raised to power 0. So it becomes 1 raised to power 0, 2 raised to power 0 up to n raised to power 0. Something raised to power 0 is 1, so we get 1 plus 1 up to n terms or n times. So we get n into 1, that is n. Therefore, sigma of constant term 1 from 1 to n is n. Now the fourth property is sigma I1 to n constant m, that is 2, 3, you can say any constant. So we can write it m into 1, so it can be written as m times using second property sigma I1 to n 1. So using third property sigma I1 to n 1 is n. So it becomes m into n. That is the number of terms. If we have to find I1 to 5, it becomes 5m. The fifth is sigma I1 to n product of two series is not equal to individual product of two series. Sum is okay, but product is not okay. Now the sixth property is sigma I1 to n ai over bi, that is a quotient. It is not equal to individual quotient of two series. So remember these points so that while solving such type of series we can involve these properties of sigma. And in the quotient of series, bi should not be equal to 0. That is the property of rational numbers. And as we know, by using AP series, the sum of first n natural numbers, that is 1 plus 2 plus 3 up to n, is equal to n into n plus 1 over 2. Now we can write it as sigma I1 to n, that is I is equal to n into n plus 1 over 2. Now we will find sum of some special series just like sum of squares of natural numbers and sum of cubes of natural numbers. That is, in sigma notation, it can be written as we have to find sigma r1 to n r square and sigma r1 to n r cube. These are the special sequence as we discussed earlier, and by sigma notation this can be written as we have to find sum of squares of natural number and sum of cube of natural number. Now we will do theorem 8 that involves sigma r1 to n r square is equal to n into n plus 1 into 2n plus 1 over 6 for all n belongs to natural number. Now we have to find the sum of square of natural number in theorem 8. Here Sn is equal to r1 to n r square is 1 square, 2 square, 3 square up to n square. For solving this, we consider the identity. That is a hint to solve such type of problem. That is x cube minus x minus 1 whole cube is equal to 3x square minus 3x plus 1. If you get the difference of this, you will get this answer, a cube minus b cube. That is, we get, now put x is equal to 1, 2 up to n, we get 1 cube minus 0 cube is equal to 3 into 1 square minus 3 into 1 plus 1. That is 2 cube minus 1 cube is equal to 3 into 2 square minus 3 into 2 plus 1. That is 3 cube minus 2 cube is equal to 3 into 3 square minus 3 into 3 plus 1. So on, we will get n cube minus n minus 1 whole cube is equal to 3n square minus 3n plus 1. So if we see, this is the cancel out mean is just like this. So these terms will be cancelled out, and on adding we get n cube minus 0 cube is equal to 3 into 1 square, 2 square up to n square. That is our requirement. Minus 3, 1 plus 2 plus up to n plus 1 plus 1 plus 1 up to n times. So we get n cube is equal to 3 into Sn minus 3 into sum of n terms of AP series is n into n plus 1 over 2 minus n. So by taking the LCM, we will get Sn is equal to 2n cube plus 3n square plus 3n minus 2n over 6. So we get 1 over 6, 2n cube plus 3n square plus n. So we get n over 6 is equal to into 2n square plus 3n plus 1. So in the bracket we get quadratic form, so it will be factorized. So it becomes 2n square plus 2n plus n plus 1. Therefore we get n over 2, sorry, not n over 2, it is n over 6. Just see. So we get 2 into n plus 1 in the bracket n plus 1. So we get n into here 2n. 2n is common out, n plus 1 n plus 1. While doing calculation, just concentrate on the calculation. Otherwise you see I have done so many mistakes. So just concentrate. We get n into 2n plus 1 n plus 1 over 6. So we get Sn, which is equal to summation r1 to n r square is equal to n into 2n plus 1 into n plus 1 over 6. So this is the sum of square of natural number. Now the next theorem is theorem 9, that involves sum of cube, that is sigma r1 to n r cube is equal to n square into n plus 1 whole square over 4 for all n belongs to natural numbers. That is, proof is here Sn is equal to 1 cube, 2 cube, so on up to n cube. And we have to find this. Now we consider the identity as in this case we will consider x4. As in the previous case we consider x cube. So this is a hint to solve such type of problem. So we will solve identity x4 minus 1 minus x raised to power 4 is equal to, you can solve it by using binomial theorem 1 minus x raised to power 4. So we get 4x cube minus 6x square plus 4x minus 1. Now after choosing the identity, problem become very easy. Now put x is equal to 1 to up to n. We get 1 raised to power 4 minus 0 raised to power 4 is equal to 4 into 1 cube minus 6 into 1 square plus 4 into 1 minus 1. Now on substituting 2, we get 2 raised to power 4 minus 1 raised to power 4 is equal to 4 into 2 square minus 6 into 4 into 2 cube 6 into 2 square plus 4 into 2 minus 1. Now substituting x is equal to 3, it becomes 3 raised to power 4 minus 2 raised to power 4, 4 into 3 cube minus 6 into 3 square plus 4 into 3 minus 1 and so on. We get n raised to power 4 minus n minus 1 raised to power 4, 4 into n cube minus 6 into n square plus 4 into n minus 1. So on adding we get we will get n raised to power 4 minus 0 raised to power 4 is equal to 4 times 1 cube up to n cube minus 6 into 1 square up to n square plus 4 into 1 plus up to n minus 1 plus 1 up to n times. So we get n raised to power 4 is equal to 4 times Sn minus 6 into summation r1 to n r square plus 4 summation r1 to n r minus 1 into n is n. So we get that is n raised to power 4 is equal to 4 into Sn minus 6 into 1 by 6 2n plus 1 into n plus 1 plus 4 into n plus 1 over 2 minus n. Now Sn be taken out here and by taking the LCM we get 1 by 4 in the bracket n raised to power 4 plus 6 and 6 is cancelled out. So we get n into n plus 1, 2n plus 1 minus 2 times n into n plus 1 plus n plus n does not involve this. So we get up to this term and 1 by 4 is with all terms. So from all the terms we get n is common out. So we get n cube plus n plus 1 into 2n plus 1 minus 2 into n plus 1 plus 1. So we get 1 by 4 n cube multiplying these brackets n 2n square plus n plus 2n plus 1 minus 2n minus 2 plus 1. So we get 1 by 4 into n, that is n cube plus 2n square, 2n minus 2n is cancelled out and 2n square is always, n is always 1 and 1 is 2 and this is minus 2, this will be cancelled out. So we get these terms. So we see n is again common out and we get n square plus 2n plus 1. So this is the form of n plus 1 whole square a square plus b square plus 2ab. So we get 1 by 4 n square n plus 1 whole square. That is, we get Sn sigma r1 to n r cube is equal to n into n plus 1 over 2 whole square. If we see, this is the summation of sum of n natural number of AP series. That is the whole square of that term. So this was all about the sum special series.